everybody. So we're doing the partitioning and the geometric mean review. Here we go. So for all of these, you want to realize that you want to graph it, and a ratio, anytime you see this, you want to remember that anytime you have a ratio of 1 to 3, that means you have a total of 4 pieces. Someone's getting 1, someone's getting 3. So you graph your points, label them A and B. This goes in order. So person A will get 1 piece, person B will get 3 pieces after I do this part. So again, step 1 is to graph it, which I've already done. And now I make my right triangle by simply connecting the horizontal and vertical distances. That's always step 1. And now we count. So the distance from here to here is 1, 2, 3, 4, 5, 6, 7, 8. But remember, I need to divide that into 4 equal pieces. So 8 divided by 4 is 2. So every two marks, I will cut a piece. So there's 1 piece, 2 piece, 1, 2, 3 pieces, 1, 2, 4 pieces. So there's my 4 pieces on A. Now I'll count my distance vertically. So B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, I'm dividing that by 4. So I get 3. So every 3 pieces, 1, 2, 3, I make a piece. 1, 2, 3, I make a piece. 1, 2, 3, and 1, 2, 3 again. So I have a total of 1, 2, 3, 4 pieces, and a total of 4 pieces that way. A is getting, because of the order, A is going to get the 1 for the 1 to 3 ratio. So from A, I'll go 1, I'll go straight up. From B, and this is mostly just to check, I'll go 1, 2, 3, and go straight across. So they meet right there at the coordinate, and now I go back to my origin. The coordinate is 1, 1. So my final answer would be 1, 1. The second question, again, I would draw my right triangle. So that's in. My distance from A to B is 8. My distance from B to A this way is 2. It's a 5 to 1 ratio. So this one is one of the really, really tricky ones, okay? So again, let me just make sure I graphed correctly. So 2, 8, 10, 10, definitely graphed correctly. The reason why this one is tricky is because a 5 to 1 ratio is a total of 6 pieces. So that means I need to divide 8 by 6 and 2 by 6, which means that it's not going to be pretty. This would be, I call a pretty one. This is not a pretty one. So you want to get the decimal approximation when this happens. So if you grab your calculator, hopefully you can see it okay on there. You'll go here and you'll do 8 divided by 6, okay? And then after the 6, I'm going to put a decimal point, and that's going to quickly give me 1.3 repeating. Okay, so roughly 1.3. 2/6 is the same thing. Actually, it's 1/3, so this would just be 0.3 repeating. Same thing, I just meant decimal wise, but again, so 2 divided by 6, put that decimal point, and I get that 0.3. Okay. So I know that I'm going to have a total of 6 pieces here, so I'm just going to kind of have to guess on that a little. So like, okay, here's 1, another one, 2, 3, 4, 5, 6, and then here it's like 1, 2, 3, 4, 5, 6. It's really, really, really tiny. The reason I draw that is because it's just going to help me think through this. I know that on my x-axis, this is 2, so I'm going to the right. Okay. Person A is going to get 5 pieces, so I'm going like almost all the way to here. And I'm counting 1.3 every time. So like this is 1.3, this is 1.3, this is 1.3, this is 1.3, this is 1.3. So 2 is getting added 1.3 5 separate times. This is how I'd have to think through this one. So then I'll just grab the calculator, 2 plus 1.3 times 5, and that gives me 8.5. So I know my x coordinate would be 8.5. And then my y coordinate, I'm starting at 10, I'm going downwards, right? Okay, and that's getting 1 piece. So it's just getting minus 0.3. I'm just going down 0.3. So this would be 9.7. So that's super duper ugly, but it's how this one would be accomplished under the circumstances. They've only ever done an ugly one time. Every other time it's been a pretty one, but I want to make sure that we've practiced all of those. Okay, moving on to number 3, a ratio of 1 to 3. So again, that's a total of 4. So if I have 1 to 3 with a total of 4, I go to my graph that I've already made, but that's always step 1. I draw in my right triangle. Again, I'm splitting it into 4, so I count 1, 2, 3, 4, 5, 6, 7, 8, divided by 4, so that's every 2. 1, 2, 1, 2, 1, 2, 1, 2. Then I count this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 4 is 3, so 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So there are my pieces that way. I go back to the question to remember who gets what. So 1 to 3, A, B. That means person A gets one of those pieces, and person B gets 1, 2, 3 of those pieces. They should always cross on the line, which they do. So now the coordinate of that is -2, +2. So those are my coordinates of my final answer. Number 4, find the coordinates of P. So we have a 3 to 4 ratio this time. So again, I add those to get 7. And then I graph it, which I already did. Okay. B is 1, 2, 3, 4, 5, 6, 7 down. Again, I don't think I said this, but you could have drawn your triangle that way. I just tend to always draw mine underneath, but it doesn't matter. That just means that every one of these is a piece, right? Because 7 divided by 7 is 1. So it's just every one, okay? And then this way I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 divided by 7 is 2. So I count every 2 pieces, and that will give me my 7 total pieces. I go back to the question. 3 to 4, A to B, so A gets 3. So A gets 3, 1, 2, 3, which means B gets 4, 1, 2, 3, 4. Again, they should always meet on the line. So this is, here's my origin, so -3, 1, 2, 3, 4, 5, 6. -3, -6 is my final answer. So that's how you work through partition questions. Now we're going to move to geometric mean. What you want to remember for any of these, it is always going to be a right triangle split into 2 other right triangles. This line doesn't always have to be dotted. It could be solid. Don't worry about the dotted part. You always start at the right angle of the largest triangle. Whatever stems from that is the part that repeats. This comes from similar triangles as a reminder. I'm just showing you how to do them quickly. If I go down X, remember X is part of this small triangle, which has 36. It doesn't matter where you put the 36. And then it also is part of the largest triangle, which is going to have that whole distance. So 36 and 64 together make 100. From here, you would cross multiply. So 100 times 36, x times x squared. And then what you would have to remember is to take the square root of that to get your final answer, which would be 60, I believe. I did that in my head, but you would take the square root to do that. Number 6, I'm just going to fold this paper so it's easier for me to move it to the camera. Again, I start at the right angle of the largest triangle. There's my large triangle. There's its right angle. Here is the part that will repeat. X is a part of the small triangle and the medium triangle. So you'll see that 36, I also need 64 here. So 36 and 64 are going to be my other 2 pieces. So I cross multiply, I get x squared equals whatever 64 times 36 is. It's 2,304. To solve for x, I take the square root of both sides, and I get 48. Okay. Now it says simplest radical form. If you always want to check if it reduces, if it doesn't evenly reduce, you can just go to there. That's fine for now. Right angle there. 15 is the part that's going to repeat. That's always step 1. And now this is labeled nicely because it's the 9 is part of the small triangle, and then the x is a part of the big triangle. So 9 and x, 15 times 15 is 225. 9 times x is 9x. We divide by 9 on both sides and end up with 25 as our x. This way I have 48. So 48 is going to be the part that repeats. It doesn't always have to be x, just as a reminder. And I knew that that was the right angle because this is the large triangle, so that's the right angle. And then again, it's the small triangle and the medium triangle, which means x and 36 are exactly what I need. Cross multiply, and you end up with 36 equals 2,304. We divide by 36 and end with 64. Okay. Moving on to number 9, again, I find my large right triangle. There's the right angle, so 48 is the part that repeats. This is part of the small triangle and the medium triangle, so x and 64 are the other two pieces. 48 times 48 is still 2,304. I get 64x. When I divide by 64 on both sides, I end up with 36 equals x. Large right triangle, there's the right angle, so 60 is my repeating part. Remember, repeating part always has to go crisscross. And I always tend to put them top, left, bottom, right, but you can put them the other way, just as a reminder. And then this is a part of the small triangle and the big triangle, because it's on the outside. So 36 and x are exactly what I need. If I needed this piece, I would call it x minus 36, just as a heads up on that. So I get 3,600 equals 36x. Divide by 36 on both sides, and I get x equals 100. Moving on to the back, I'm just going to set them up because you know how to cross multiply. So here I go. 12 and 12, and then x and 9, because x and 9 are the two pieces touching that path. We have this. 12 again would be your repeating part. 16 and x are your other two pieces. 48, so this one's a trickier one. 48 is my repeating part. Okay, but now 64 and this piece are what I'm looking for. So you have two options. You can call this y, and then when you solve for x, add that number and that number at the end. Or you can call this the whole thing minus 64, which would be x minus 64. So 48 repeats with 64 and x minus 64. When you cross multiply, this needs to distribute. So it would be 64x minus 64 times 64 is 4,096 equals 2,304. Add to both sides. You end up with 64x equals 6,400, and then when you divide, x ends up being 100 for that one. But that's how you deal with a circumstance when you don't have the part you need. Same thing here, 12 would be the repeating part, because that's the right angle of the large triangle. Because 12 is the middle, you need 9 in this piece, so this piece would be called x minus 9. Here I have my right angle. 60 is my repeating piece. 60 is a part of the small triangle with 36, and then also part of the large triangle with x plus 36 or 36 plus x, however you want to write that. Again, remember to distribute your 36. And finally, my right triangle is here, so 15 is my repeating piece. 9 is the first part because it's part of the small triangle 15 is a part of, and then 9 plus x is the second piece because it's a part of the big triangle. And again, that can be written as x plus 9. Cross multiply, do not forget to distribute the 9. And you solve. So that's how you do partitions and geometric mean. Have a great day.